Okay, so having a look at this example here, we're testing for a Poisson distribution. So you've got the number of telephone calls arriving at an exchange in 60-minute periods. They were recorded over a period of 8 hours with the following results. Can these results be modeled by a Poisson distribution? Test at the 5% significance level. Well, with the Poisson distribution, we need lambda. Lambda, remember, is the mean. So you have got a frequency table there, and you just use your statistic functions to work out the mean. And so you just put that into your table. So you should have an X column, frequency column on your calculator, and you are bringing up X bar. And if you bring up X bar on your calculator, you will get that the mean is 2.2. Okay, and that is going to be your lambda. Okay, so that's going to be your lambda. And then your H0 is the observed data can be modeled by a Poisson distribution. And your alternative hypothesis is that the observed data cannot be modeled by a Poisson distribution. Okay, so I've drawn my table out again. And I'm using the Poisson function on my calculator to get the probability that x equals 0 when lambda is 2.2. So if you get that, you'll get 0.1108. When x equals 1 and lambda is 2.2, my probability is 0.2438. So I've done that for all of them. Okay, and then to work out my expected values, I have done my total frequency, which was 80, and I've times it by the probability. So that's my first expected value, and I've done the same with the next one, 0.2438, times it by 80, you would get 19.504, and so on. Okay, so I've done it with all of them. Now, if you have a look at my last three expected values, they're all smaller than 1, which is, sorry, they're all smaller than 5. So I'm going to combine all of them to get 5.8. So I'm looking for these values here going to be bigger than 5. Which gives me 5.8. And my observed values, they're all the same. The last three were 5, 1, and 1, and I've combined it to give you 7. And then I'm just going to use that formula again to work out my observed minus expected squared, all over expected. I'm going to find some of that. So my first one, observed 8, minus expected 8.864, square it, divide it by the expected value, plus, you do the same with the next one. You say observed 19, take off expected 19.504, all squared, and you divide it by the expected, and so on. And if you do that with all of them, you would get 2.102. Okay, now your degrees of freedom, we have got 1, 2, 3, 4, 5, 6, because I've combined them all, 6 boxes essentially. So 6, and I'm taking off 2. The reason why I'm taking off 2 rather than 1 is that I had to work out my mean there. So if you're having to calculate lambda, just like before we had to calculate p, if you have to calculate lambda, you don't take off 1, you take off 2, which gives me my degrees of freedom, which is 4. My significance level, I think, is 5%. And then you go to your tables again. So again, I'm going to get my book out. I'm going to go to my tables. I'm going to go to degrees of freedom, which is 4. I'm going to go along to 5%, which is that one there, which gives me 9.488. There it is. And then I'm going to compare the two values. And again, you can see from the diagram that 2.102 is not inside the critical region. It would be somewhere here. So you say it's not significant. You do not reject H no, and then you write your statement again, which means you write insufficient evidence to conclude that the observed data cannot be modelled by a Poisson distribution. Okay.